8.7, the last in chapter 8, and we're going to talk about probability. The previous lesson talked a lot about how to count up options or how many scenarios or how many outcomes there are, and now we're going to talk about the probability, actually finding out the probability of something happening. And we're going to start with coins tossing, and we're going to start off by drawing actually a probability tree. And so off to the side, I'm just going to write the first coin that's tossed has two options. It either comes up heads or it comes up tails. Those are it. When you toss the second coin, that can flip either heads or tails onto or after the first coin gets tossed. So you could toss a heads heads, you could toss a heads tails, you could toss tails heads or tails tails. And then the third coin, this is as far out as we're going to go, we'll do it again. So you're creating all of these branches of opportunity or of chances for something to happen. So there are 1, 2, 3, 4, 5, 6, 7, 8 different outcomes that could happen. Could have heads, heads, heads. Could have heads, heads, tail. And I'm kind of just following the trail or the branch. Heads, tail, head. Heads, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. And tail, tail, tail. So now when I'm coming over here and answering my question, it says find the sample space for each of the following. One coin toss is just heads, tails. That's it. You either get a heads or you get a tails. Whoops, I just did that in the wrong place. 2 coins tossed, you can get heads, heads. You can get heads, tails. Squeeze that in there like that. You can get a tail head, and you can get a tail, tail. 3 coins tossed is this list right here. All of those 8 options. So our first example says 2 coins are tossed. What's the probability that both land heads up? So 2 coins. So I only want to look that far. I don't want to look any farther than my second coin toss. So what's the probability that they both land heads up? There's only one branch that has heads, heads out of 1, 2, 3, 4 different possibilities. Or if you look here, there's only one that was heads, heads out of 4 possibilities. So 1 out of 4. What is the probability that a card is drawn from a standard, what is the probability that a card is drawn from a standard deck of playing cards is an ace? So we have talked before about our cards, and we have 4 aces in the deck and there are a total of 52 cards, so 4 out of 52, which is an acceptable answer. If you want to reduce it, it's 1 over 13. This actually tells me a little bit more about how you did the problem. So if you mess up here or you wrote 8 instead, I would know what part of the fraction you were getting wrong. Once you start to reduce it, then the math could trip you up as well. So this is actually more helpful than the reduce because I can kind of see what you were going after for an idea. Next up, 2 6-sided dice are tossed. What's the probability that a total of 7 is rolled? So we kind of want to make our list of what can happen. So if I roll a 1, the match to make 7 would be 6. If I roll a 2, it would be 5, 3, 4, 4, 3, 5, 2, and 6, 1. So there are 6 different things that could happen and now we need to talk about how many different things can happen when you toss 2 dice. I'm going to just briefly make the probability tree, same as I did up there for coins. So if I roll a 1 the first time, these are all my choices for a roll. I roll a 1. The second time I roll something, there are 6 chances, 6 options of things. Like you get a 1, 2, 3, 4, 5, or 6. Same with the 2. Same with the 3. And so when I multiply this, there's 6 options there, 6 there, 6, 6, 6, 6. I end up with 6 out of 36. And again, this is totally legit. You could also write me 1 out of 6. In a lottery game, a player chooses 6 different numbers from 1 to 38. 1 winning ticket is sold. What's the probability of winning? So if there's only 1 winning ticket, there's only one way I can get that. So its probability is a 1. There's only one way. Either I have the winning ticket or I don't. The total number of tickets that could be made, so I'm looking to arrange all of those numbers. How many different ways can I arrange them? And it doesn't matter their order. So 38 choose 6. So 1 out of 2,760,681 for winning that particular lottery. Next up, we've got some probability of multiple events. So maybe I want something or something else to happen. I need to get a 5 or a queen. And so we do the probability of getting a 5 and we add it to the probability of getting a queen, and then that's my probability. When 2 events overlap, like the probability of getting a queen or a heart, because there are some queens that are hearts, you still do the probability of queens, hearts, and then what you do is you subtract out the overlap, anything where they both occur. And our last example is the probability of something and something happening. So maybe I need an 8 and a 5 to fill out my hand for poker. So then that's where we're going to multiply. Our options here are going to go way down. Our probability is going to go way down because we need two things to happen. It's not an or. This is an and. I need them both to happen. So one card is selected from a deck. What's probably the card is either a heart, or a face card. So that's my keyword there, or. So we're going to be looking at either this one or this one. Again, or. We have some hearts and we have some face cards. We do have some face cards that are hearts. So we have overlap. So I'm going to be looking at this formula. So I'm kind of looking at the probability of hearts, and then I need the probability of face cards. So hearts, if I look at my card, or if you remember how many there are 13 hearts out of 52 cards. Probability of face card, there are 12 face cards out of 52. Now I can't just add them together because again, we have to talk about our overlap. There are some cards that are both hearts right here and face cards up here. And there are 3 of them that overlap. So out of all of the hearts right there and all of the face cards right there, there are 3 that overlap, which means I have to take 3 back out because I've counted them twice. So I'm just taking them back out of the equation. And I end up, when you do that math, you end up with 22 over 52. Lots of students choose not to use this formula, and they just go ahead and they count all of the cards that are a heart or a face card. So they count up their hearts, and then they count up their face cards, and they're already at 22, and they don't worry about the overlap because they're taking the time to count. And you can do that either way. Last one, it says 3 numbers between 1 and 20 are chosen at random by a computer. What's the probability that all 3 numbers are less than or equal to 5? So the numbers that are less than or equal to 5 are 1, 2, 3, 4, and 5. Those are all the numbers. So the very first number I go to choose, or that the computer spits out at me, I have a 5 in 20 chance that it's going to be the number I need. And I need the next one because I want all 3. So I need the next one to also be a 5 out of 20 chance. And I need the next one to be a 5 out of 20 chance. And it says that we're multiplying because our odds of this happening are going way, way down. So we're going to multiply, and these numbers are going to get very big, which means my probability went way down. Typing this in your calculator, you end up with 1 over 64. You have a 1 in 64 chance that you're going to get all 3 to come up less than or equal to 5. So our main things today are determining probability here. If you're an or statement, you're going to be adding, and if you're an and